Hello everyone. So today I come back with the second part of 1.7. But I would say this page supposed to be in section supposed to move to I would say supposed to move to the graphing section like 1.4. So like after page 17, I would say that. So because this is kind of like so different with the one in session 1.7. But anyway, that's okay to I would say move this page to page to be at the page 16. Okay, so yeah, say section. Yeah, so anyway, that's okay to teach you right here with it. So everyone know that we have a company manufacture sell X toaster ovens per week, and weekly price, demand, and cost function have been given below here as P of X equal to 80 minus 2X, and the cost function is 600 plus 5X. So keep in mind that we have revenues revenue function can be write as say revenue. Let me write it down here. Revenue can be write as can be built as demand time with price, right? So and in here, as you see that demand was X and price was P of X as a function that you are given there. So so you can actually substitute that, substitute the PX there and make the revenue function as X will be equal to X, and then the time with P of X there change to be 8D minus 2 times X, right? And keep in mind that this was given from the function price, right? As I highlight with yellow color there. So so that is how we develop the function of revenue. Now we need to do, let's check the question. We need to add the cost function to the graph. So the graph right now is actually giving us, I would say, graph has function revenue X there, right? Maybe I'm gonna say that we are having graph function, a revenue function. Right. So this is the function of X here. Okay, and the blue one. We need to draw the graph of cost function. How can I do that? So I know that according to the cost function there, we have C of x equal to 600 plus 5x. We can find the we have fixed cost right away, right? We have fixed cost. Which is 600. 600. So this will be actually a y-intercept of the cost function of the graph, right? So then it's going to be 0, 600, the point. Okay, and another point we maybe need to, you know, to use could be like, you know, we can use we can make, or I can make a t tables. All right, let's make a t table here. Say x here and then c of x here. I'm going to use red color for that. So x was 0, max 600 for the cost function, right? And if I make, let's choose at 40 here, right? If I have 40 items, how much I have to pay for the cost? So 40, you substitute C of 40. What is that going to be? It's going to be 600 plus 5 times 40. And that's going to be equal to 600 plus 200, which is 800. So that's the reason why I put down 800 here. And I have this as 0, 600, and this another one as 40, 800. Right. So I have 2 points. One was this one. Another one is 40, and that's going to be this one. And I'm going to draw the line, go through the 2 points. All right. So that's going to be the cost function. Okay. That's going to be the cost function. Okay, now they say in the break-even point. So keep in mind that we need to have definition of break-even point, right? I would like to put down the break-even over here. Definition of break-even. Whoa, what is a break-even point in business? Okay, think of that. Okay, so break-even point in business is going to be the case that's the point that make that have, or that I would say that have expense or cost equal to revenue. We mean you don't make any money, right? You don't make any profit actually in this case, right? So this is bad. Okay, so you look at the graph, try to see the quick point that the cost function and revenue function, they are equal each other, right? So you will see right away the point over here. There's 2 points. Okay. So this. There are 2 points on the graph. Okay, I group approximately. Let's see what is this. Okay. Right. Okay. I group approximately it was 11 point 11 point somethings. Okay, so let's say 11.5 approximately, right? At x equal to 11.5, something like that here. And the other point was at x equal to 26.5. Let's say that, right, about that. So we have 2 Ks on the graph. And in that case, we have break even. Right. We don't make any money in here. Okay. Cost and revenues equal each other. Okay. So I would say I would write here is according to the graph, we can estimate that at x equal to 11.5 and x equal to 26.5, we will have break-even point. Right? Okay. Okay. So did this estimate? Okay. By eye, I can only say that. But if you really want to see like what clearly is, what is that point, you may have to use decimals. Okay, let me show you how to use decimals in this case. All right. So you put out the function of cost Cx equal to secondus plus 5x, right? And you put out revenue function x equal to x times with 80 minus 2x, right? So right now you don't see a good graph. You may have to, adjust. You may need to zoom out a little bit to see, oh, okay, something that's showing you right now, not nicely. Okay, we don't need we don't need the negative side, we need the positive only. But I want to adjust this to make my graph to be the best and show my boss. So first I need the highest part was address for the for the y values. I need the x maximum going to be about 40. So I'm gonna adjust the x-axis to be in between maybe 0 to, I want to say 45, because I want to bound it, right? And I label my x was the demand, right? Demand. Okay. And the y, demand x, okay. And the y gonna be, I'm gonna say from 0 and up to, I'm gonna say 900, right? Maybe adjust this to be like 41 enough. Yeah, that should be okay. Okay, so why gonna be because this present both revenues and costs. I would say dollar sign. Okay, amount money in dollar, right? All right. So that gonna be that's gonna be the graph. You need to show the boss. And break-even point right now clearly it was 11.56 somethings, and another one was 25.9 something. Okay, my graph and my graphical way was kind of not perfect answer, but at least you have some ideas for break-even points, right? And again, if you want to show the bot, you need to use this mode on that. Okay. So I would like to go back to this and okay. Thing is it was here. All right, so let me put it down. Need to show on decimals. Okay, I'm gonna add this one. So okay, so I have break-even points. Okay, and I want to tell you that how can you make profit? All right, think about how can you make the profit? How can you make money? Right? In order to make profit, you need the K that revenue. The revenues must be higher than the cost. Okay. Okay. So let me write. Let me make this to be small. Okay, better. Okay. So as you see right now, there is area over here. Okay. That areas is in between the break-even point there, right? Between the two break-even point there. I will use the green one here. Right. So when demand in between to this number, right, you will make profit. You will make profit. Okay. Yeah. Okay, you will make profit here. Right. So you want as an accountant or business, you want to make sure the boss trying to have business get the demand in between 11.5 to up to 25, something like that. So you don't want to ask them to try to get like before 11.5, or maybe like think about like 10, right? And think about as the area there. Let me use the black color here, right? And you see the area here. You see that area cost higher than revenues in this case, right? You see that's case, right? Both of this area, the area outside, like after and before the break even, they made the K that's cost, the function of cost is above revenues, right? Cost above revenues, right? So that's K make loss, right? right? So here, loss. Okay. So keep in mind that and in accounting, you have to um, say if you want to make profit, you should try to have demand in between, like, 11.6 and maybe I don't see, 26.5. I would like to use the, see, I see this already, so I would like to say 26. Okay, let's use 26. And 26, right? To make it more accurate. Okay. And I use add color here, green one. Okay. And another one, gonna say, if you have demand, like demand less than demand in the interval as from 0 to 11.5, or 11.6, say that, right? Or 11, so or 26 to, I know, greater than 26. Yeah, let's see. Let me just say, like, demand less than, like outside that 11.5, or greater than 26. Right? You will get lost, right? Okay, so this is see the way we do for this one, right? So the next one gonna be similar. You can go ahead and try to do this problem in 3 minutes. You pause and then you can pause my video and try. Okay, so so in few minutes, when you're done, just please play my video. Okay. Okay, so you did have you should have the revenue function as given there, and the cost function will be with 2 points that you can use two tables there as 0, 500, and 30 and 620. I usually gonna use the 30 because at x equal 30 there is gonna be the point that, I mean, the maximum you consider with, since after that you're gonna have the negative of the revenue function, right? So I did add the cost function to the graph. Okay. And I also have the break-even point. I mean, if you need the perfect point, again, you should also look at the decimals, and on decimal it show you like it's about 8.1 and 20.5, something like that. So yeah, I should say, like, I should say in here is break even points at x equal to 8.1 and 20.5 approximately. Okay. So since these are by x, we don't want to say exactly, okay, but I mean, you know the way using decimals, you can show the work, show the exact number to those box. Okay. Okay, so and again, what is the area that make profit? This is the area that use or the boss want to get. Okay, make profit. Okay, so here in between two two break-even point, and you don't want to get the loss, so you don't want the area that make the cost higher than the revenue, right? So which is these two area here that you will have loss, right? Loss. Yeah. So here's profit, make profit, and that is break-even point. Yeah, to this point, the break-even point. All right, so we're done with section 1.7 part 2. I would like to go ahead and move to the next section now. Okay, so let's move on. Okay, so we move to 1.8, quadratic function. All right. Okay, so we are in quadratic functions, and quadratic function is having a graph look like a parabola. Okay, so and I'll say with parabola graph. So parabola graph could be, like open up or open down, like that, right? So I would like to first start with standard form of the quadratic functions. So standard form of quadratic function is in the form as f of x equal to ax squared plus bx plus c, where a is not equal to 0. Keep in mind that you don't want to have a equal to 0, since if you have a equal to 0, you want to make just bx plus c. We come back to the linear, right? So a can be less than 0 or a can be greater than 0. So we're going to split this to be two cases, which is a greater than 0 and a less than 0. So a greater than 0s, we have concave up, which is graph as a parabola upward. And if a is less than 0s, you're going to have concave down, which is a parabola downward. So as you see below here, usually you see this parabolas as a revenue function. Okay, something in business could be a revenue function, right? Or profit function later. You want to learn about that. But okay, like I say, keep in mind that if you have a greater than zeros, I'm gonna use typing here a greater than zeros, right? You will have concave up right? What else? You will have when a less than zeros, you will have concave down. Okay, so keep in mind that in parabolas, there is a point that we call vertex, right? And in the case that it was concave up parabolas, you will have vertex is as minimum. Right, is a minimum or is a minimum value of function. Yeah. Yeah. I'll use article here. For the K, when you have concave down, you also have vertex, but in this case, vertex is a maximum value of function, right? And mostly you see your graph, your parabola in business as a concave down. Okay. So as you see in revenues function, you see that was a mostly is a parallels downward, right? Okay, now let's talk about how to find vertex. Okay. I would like to have vertex as a point, right? And I would like using say using vertex at V, and with the coordinate of x was xv and y was yv. Say that, right? Okay, so v. Yeah. All right. So now let's we try to have vertex. Try to have the vertex coordinate. How to find it? First, in order to have the x value, I'm gonna write as xv. Okay, it's gonna be xv equal to negative b over 2a, and I'm gonna cross this. And I say yv will be equal to f of xv, which is f of negative b over 2a. Let me write like that. Better. Okay, so I'm gonna need to fix this next time. Okay. Now let's do an examples. 1.28 right? We have function as 2x squared plus 12x plus 13. Okay, so we have in here, I would like to write down what's a. Let me use add Scott actually. You know what? Let's type it. A equal what? I have A equal 2 in here, right? B equal to 12, right? C equal to 13, right? Because as you see right here, I have ax plus by, ax squared plus bx plus c, right? So, so right now I have a equal 2 and b equal to 12, c equal to 13, okay? So now we need to find the coordinate of the vertex and determine if the vertex is maximum or minimum. So let's find it, right? So we have xv by the formulas equal to negative b over 2a, and I'm gonna substitute. So negative b was 12 over 2 times with a was 2. And you want to use the calculators, and you should have the answer at negative 3. Okay. and now for the y values. Okay, it's gonna be f of xv, and I know that xv was negative 3, right? So it's gonna be f of negative 3, and I need to using the function that they are giving me here, right? And I substitute negative 3 as input into that function. 2 of negative 3 square plus 12 times negative 3 plus 13. Okay, so last you know what, I'm gonna move that here. So last we have, so yv gonna be what? 2 times 9, right? Gonna be 18 plus 12 times negative 3. Okay, let's change that to be negative 36, right? And then plus 13. Okay, so use the calculators. You should have negative 5, right? So we can say vertex v gonna be in the form as xv yv will equal to negative 3 comma negative 5. All right, so so we need to know it is a maximum or minimum, right? Let me use other colors. We have a was equal to 2, which is greater than 0. So vertex is a minimum, right? Because you see that if a was greater than 0, it's going to be like upward polarized, right? So then the vertex would be the minimum, all right? Okay, so that is for example 1.28. Okay. And if I want to say something like, say like function has minimum at x equal to negative 3 and y equal to negative 5. Okay, so you can state like that. All right. That's it. All right, so now go ahead and try the exercise 1.22 below here in 5 minutes, and then we're gonna come back and go together. All right, try to find the vertex and tell me if it is maximum or minimum, right? Okay, so go ahead and pause my videos in 5 minutes and come back, okay? Okay, so let me show you what I did. First, I just want to have my answer key according to the most. I put down the function of mx first, and I saw that the function was that word right away, right? And I click on the function. I see the vertex was 2, 7. All right, this is my answer key. Okay. So what I do is now I can go back to the columns. Okay, and I list out A, B, C. I know that A was -1. It might be negative, right, less than 0. So that's give us a can keep down. We also give me a maximum value at vertex. Then I find the vertex coordinate. So xv will be negative b over 2a. We're going to be equal to 2. As you see, my answer key must be 2, 7, right? So 2 was correct. And then yv is by using substitute the value of xv that I just found, substitute into the function fx. It was negative x squared, and now I change x to be 2, right? And so it's square, and plus 4 times 2 plus 3. So I think most of you must maybe watch out at this point here, because someone gonna say, oh, so that's mean -2 all this square. But actually, no, it actually gonna be this negative is outside of this guy. Okay, this is just the 2 square. So that's the reason why after you square you have 4, and you still have negative. Okay, so for -4, stay with it. And plus a plus 3, and I simplify gonna be 7. So the answer will be 2, 7, and vertex will be in maximum. Similarly, I'm using Desmos and got, let me turn off this, and then got the g of x here as a function upward, right? Upward parallels. And I click on that, I see right where the answer can be in 2 and -8. Okay, so I made something wrong here, and you see, right? What did I do wrong? Okay, so let's check. So I have 2 as a equal, a equal to 2 is greater than 0. So we make a parallel upward and make minimum. Okay, so now I'm gonna have x coordinate of vertex gonna be the negative of b is -8 here, right? I put out and divided by 2 times a, 2 times with 2. So 8 out of 4 gonna be equal to 2. That's maybe correct one, right? But watch out with the yv because I made mistakes here somewhere. Okay, so I have g up 2. I substitute the x inside of the function here. G of 2 gonna be 2 times 2 squared. This is a mistake that this is correct still. So 2 times 2 squared minus 8 times 2. 2 times 2 squared gonna be what? 8. Okay, so this is supposed to be 8. Let me, you know what? Clean it up. Okay, and 8 minus 16, I have to change this, right? 8 minus 16 will be equal to 7. So, sorry. Could be 8. Why I put a 7? All right, 8. Yeah. So that's supposed to be the answer. All right. So one of the way you should do is I mean Desmos did have you a lot to check the answer key, right? So I would suggest that you using Desmos to you know to have the answer key before before getting into it. Um, so you when you have answer, compare with that, and you will get you will know if you are doing correct or not. Okay. Okay, so now we're gonna move to the next page. Okay, so the next page. So before we did learn about the okay, so we did learn about the standard form, right? Standard form is a x. Let's write f of x equal to a times x to power 2 plus bx plus c, right? But there is another form for the quadratic functions we call vertex form. Okay, so vertex form is a form as f of x equals to a times x minus a squared plus k, and I mean now we have somethings for vertex which is h and k, right? So keep in mind that h is actually xv and k actually yv, right? Right. So the coordinate I mean the x coordinate of vertex and the y coordinate of vertex using the h comma k. Okay, so that's that is the one that you can from now using instead of using the letters xv and yv. Okay, so it's kind of like just a label, but most of mathematics since using that letters. Okay, so now we can try to find the vertices of the polars according to the vertex form. Okay, so let's do example 1.19 here. I have Lx equal to 2 plus 3 square minus 5. Okay, so keep in mind that I have the form as Lx equal to a times x minus h square plus k. So I need to try to convert these back into the form, look like into that form, right? So let me try that. Okay, so Lx. I write as 2 stay there, and then x. Okay, I need the minus, so minus. Okay, so it was plus 3. So if I want to have minus, then I'm gonna say minus for -3. You guys okay with that? All right. And square stay there. Okay. Square stay there. I'm gonna put down square. Okay. And plus k, right? So I put out the plus sign here, and the k's, and there's -5 here. I just gonna need to put out -5 here to make it the same value as before. Okay, so according to the vertex form, now I can know that h is -3 and k's equal to -5. All right, and you see that this is h and this is k. All right. So vertex will be in the form as s comma k, and s will be equal to -3 comma -5. Okay. Part B gonna be easier than part A since it's already in the form. Exactly, I mean exactly with negative and positive for H and K already. So we can just right away straightforward say H here and K here. So then vertex will be H comma K, which equal to 4 comma 1. Right? And you see that I have minus, have H, right? So exactly what I need. So I don't have to convert back to have the I don't have to convert the negative things there. So I can right away have the corresponding H and K from this form. So this is the reason why we call this form a vertex form, because we are given, we can see the vertex in this form, right? Yeah. So according to this rule, if you see, like, note that if we have something like x plus I don't know, maybe something like x plus x plus never mind, just you can, according to this rule, I don't want to note it down, but the thing in here is, if you see in the square group here, it was x plus a constant, then this constant you can just flip the sign, and that's gonna be h, right? And similarly, after that, if you subtract instead of plus, like the original one, you can just flip the sign of the negative here to be, you know, to be the k. So so that's gonna be it. Okay. Okay, now we're gonna move to 1.23 to practice with vertex here. So as you see, we have the form right now is look like exactly vertex form as a x minus h squared plus k. So you can right away have vertex going to be h comma k, which is equal to 3 comma 6, right? Okay, so you can go ahead and try B and C. Okay. So you can pause mine and go ahead and try, right? So I would like to leave this for you to practice with it. Okay. So now we're gonna move down. All right. Yeah, so if you finish that, you can see B and C as answer as -2, B as -2 and -5, C as 6,0. So you might don't see the K, it was hidden here, and adding with 0, if you adding 0 in it, and you're going to see k. So according to all the problems that we did, I can note for myself as note for myself that I can note for my uh-oh, I make a mistake here. So I can note for myself that we can change the sign. We can have h as the opposite number from square term, from the term x minus 3 square, something like that, right? So as you see that if I have -3, you opposite is flip the sign, you will have 3 as a h. And just keep the k was outside term, right? So yeah, or maybe from 2 here, right? Well, actually, I don't really like this note. Just try to think about the rule. That's if you see +2 here, you just change the sign, gonna be -2, right? So, and -5 here, I don't change it, I just keep -5 here. -3, change the sign, -3 to be 3, right? 6, keep it, something like that, right? Oh, this and this one, -6 gonna be 6. Change the sign. Okay, now let's move to the next part. That is find the 0. Right? What is zeros? Zeros is when the parabolas cross the axis, right? And you in order to find the zeros, you can do like, you find the input if the output equal to 0, right? So in another word, let's say find x when f of x equals 0, something like that, right? Okay. So in order to find zeros, if the parabola is given in standard form, let's use, then you have to consider 2 cases. One case is if you can you factor? Can you factor? All right. Can you factor? And the other case is, or maybe I'm gonna say you can factor instead of saying you factor. Oh. Well, I say factorable. Okay. And the other second case gonna be like unfactorable. going to say not factor. Okay, so let's start with the case that you can factor it, right? You can factor the quadratic form. And if you can factor the quadratic form, right, it implies as 0 exists as integer or rational number. Okay, so it's going to be easy to read it from the graph. So let's we find zeros of the following quadratics here. Let me show you. First, I would suggest always using the decimal to have answer key for it. So I have I'll go this one and I say I have x squared plus with a minus with 6x, right? 6x, and then I plus with 8. Okay, so okay, now you can see right now I have z is 0. Okay, 0 was at x equal to 2, 0 was at x equal to 4. Okay, so according to the decimals, I can write where I have zeros as at 2 and 4. Okay, so I will go back here and say answer key, or maybe you say like according to decimals, we can see that zeros are at x equal to 2 and x equal to I forgot, what's that, 4, right? So let's use and let's try factor way. Okay, so let's try algebraically. Okay. So how can I try algebraically? First, I need to factor this one, but how to factor it? You might think about there is a method that's called AC methods. You had to draw the like a cross line here, and on the top here you write A times C. What is A times C equal to? You listing A, what is that equal to? 1, right? B, what is that equal to? -6. C, what is that equal to? 8. Okay, A times C will be 1 times 8 is 8. B will equal to what? -6. Okay, so keep in mind that if you have A equal to 1, okay, I'm going to call it a special case that you don't, you don't have to split it split out from 3 term to 4 term, but I explain to you more later. Now so you have A times C is 8 and B equal to -6. You need to find out two numbers that multiply equal to 8 and addition. Okay, so let me type it down. Two numbers multiply equal to 8 and addition is -6. Okay, so I'm thinking always start with multiplication first. I'm thinking to use 1 and 8 because 1 times 8 is 8. That's 35 for multiplication. But if you're adding 1 plus 8 is 9. It's not 35 for -6. So I don't want to use these two numbers. I'm going to use 2 times 3. Sorry, 2 times 4. 2 times 4 is 8. Okay. All right, that's good. 2 plus 4 is 6. Oh, almost. However, it was negative, right? So if you see that's k, you can just change it to be -2 and -4, because why? Now you know that's -2 multiplied with -4 is equal to 8, and -2 plus with -4 will be equal to -6. So these two numbers are the two numbers that we need for this. Okay, so we can, according to these two numbers, we can say we can change this form over here as f of x equal to x squared minus 2x minus 4x and plus 8. Okay, as you see that minus 2x minus 4x here is equal to -6, right? Because we just split it out to be to this term. So there is a reason why we have to split this two term, because we can apply the grouping method in this case. Right? What you do was you factor the x for the first two terms, and you have x minus 2 for the first two terms. Now I also factor using the greatest common factor for the last two terms. It was -4. Put a -4 here. Factor -4 out, and then I have x minus 2. Okay, so as you see now, to this big term have a common factor was common group as x minus 2. So then I can actually factor it to be like x minus 2, factor it out, common one, and then I have x minus 4. Okay, so and you see what happened now, -2 there, -4 there, right? So that means what? Actually we can skip some step in here. So I don't need this step. I don't even need this step. I can come right away to this step. All right. After I got the two number multiplications and additions there, right? You can right away have x minus 2 and x times with x minus 4 at the factor form. Okay. So I will delete this and then just come right away to that step. Okay. Keep in mind that it's only happen if a equal to 1. You can only do this if a equal to 1. So watch out, right? Okay, so now okay. Since a equal to 1, we can have f of x equal to x minus 2 times x minus 4, right? According to -4 and -2 and -4 here, right? So now we nullify 0 by set f of x equals 0, right? Because we, as I stated before, by x when f x equals 0, right? So then we have x minus 2 times with x minus 4 and make it equal 0. and we are having factor form, right? So we can apply zero factor properties. We can have x minus 2 equals 0, or x minus 4 equals 0. We apply zero factor property. So x minus 2 equals 0, that make x equal to 2, or x equal to 4. All right. So that exactly what I found from the Desmos. Right. Zeros are x equal to 2 and x equal to 4. All right. Okay, so now we're gonna do the same way with part B in here. However, part B have some different with A was because it's have A was 2. But before doing that, let's try this mode first. Okay, so let's get into this mode. I have 2x squared plus with x and then minus 3. Come on. Okay, so I have the 2 zeros was the intercept point, right, as negative 1.5 and 1 there, right? So okay. So I'm gonna write here. At 1.5, or actually it's like negative 2 over 3, 3 over 2. And what else? One. Okay. So we have 2 points. Show that, right? Okay. So let's we keep going with the AC method as above I show you guys. So let's try algebraically. So first, listing ABC, right? A equal what? 1? No, 2, right? B equals what? 1. C equals 2 and 3. So let's move this up here. Okay, then now we can, we can have item C, right? A and C is 2 times negative 3. What is that equal to? Negative 6. B equals to 1. Right. So you can think about the two numbers. Let's say two numbers multiplication equal to negative 6 and addition equal to 1. Right? What is that going to be? Okay, so I go using I'm thinking about using 2 and 3. Yes, I'm gonna say negative 2 and 3. So negative 2, 3 will be equal to negative 6, and negative 2 plus 3 equal to 1. So then I can say negative 2, 3 here. Okay. So then I cannot right away get into like x minus 2 and x plus 3 there. Okay. I will have to split the x to be negative 2 x and plus with 3x. So we have multiple type Lx will equal to 2x squared minus 2x plus 3x and minus 3. So then I can have fx will be equal to, I can factor the greatest common factors out for the first two terms, 2x, and I got x minus 2, no, x minus 1 actually, plus 3, factor the 3 out from the next two terms, x minus 1. And then I have fx equal to 2x time with, no, actually it's going to be x minus 1 time with 2x plus 3. Okay. Okay, so then you will have factor form all these, and you can set. Now you can set. You have x equals 0. You have x minus 1 time with 2x plus 3 equals 0. And that means x minus 1 equals 0, or 2x plus 3 equals 0. So x equals to 1, or x equal to negative 3 over 2. So there are 2 zeros that we need for this function. And the next one gonna be an exercise for you guys to practice with it. I would like to leave this for you, and maybe to give you the answer key, gonna be x equal to negative 5. Yeah, negative 5. Let me see. So negative 5 and 3. Okay, so try that, and we're gonna move to the next one. Keep in mind that we are still working on factorable quadratic case. Okay, so this case we still can handle by factorable. Okay. Okay, now so what happens if we have the case that we can't factor it? So let's we use maybe I like this one here. Okay, so in the case as you try the way that I show you, maybe but you couldn't figure out there's two number or something like that, or maybe even it's hard to figure out the two numbers, right? Then you should go by quadratic formula. Okay, so quadratic formulas can apply with non-fact table and also can apply with um, you know with the case that fact table. Okay, so both uh, both case we can using quadratic formula and still find zeros. Okay, the reason why for the case with fact tables we should use zero factor properties because it's quicker, but this one is always work. Okay, now so we have the form for quadratic formula is going to be as negative b plus or minus square root of b square over minus 4ac over 2a. Okay, so you must list out a, b, and c, and then write the form into it, right? So a was 1 in this case, I mean, get into 1.31. You see that it was 1 here, right? B gonna be -4, and C gonna be is -3, right? Okay, so let's we go ahead and I mean, why don't we just find the answer key first, right? X squared minus 4, x minus 3, right? Okay, so let's put down x squared minus 4x minus 3. Okay, so I have answer is about like -0.46 and sorry 646, right? Okay, and 4.646. So I'm gonna put that out here. -0.646, and this is gonna be 4.646. Let me make sure that it's correct one. Yeah, good. Okay, so now let's apply the quadratic formulas for this one. Okay, okay, like that you can't factor this one. Okay, or you try, you can see, say A and C's was -3 and B equal to -4, and there's no way you can factor this one, right? You can see that there's it could be like -3 times 1, but when you add them together, you cannot get -4. So so the only way for this one, you must do a x squared plus bx. I mean, you must do the quadratic formula. So it's gonna be x equal to -b plus minus square root b squared minus 4ac divided by 2a, and I substitute everything into it. So -b gonna be negative of a -4, and then I time with a sorry, plus and minus with a square root of -4 square and minus 4 times 1 and time with -3. Okay, so I will just say can't factor. Okay, so now divide by 2a, we need 2 times 1. Have x equal to 4 plus and minus square root of 16 minus or plus 12 divided by 2. That will give us as I will use as a color on now for this one. I'm gonna simplify one more time. Square root of actually no, we don't need that long. I'm gonna do like 28 divided by 2, right? So you can you can I mean at this point you can actually using calculators, I mean split it, but you know you can also simplify one more time. That's 4 plus and minus this is gonna be like 4 times 7, right? Gonna be over 2 here. It's gonna be plus and minus 2 times 7, and that's over 2 here. And we can have just you divide 2 for x term, it's gonna be 2 plus and minus square root 7. So I mean you can actually from here you can using calculator at this point. But I mean if you want to write by hand, simplify, you can simplify into here and you get like 2k's. So x equal to 2 plus square root 7, or x equal to 2 minus square root 7. So if you're using calculators, say 2 plus square root 7, right? It's gonna be this, and 2 minus square root 7. It's gonna be this, right? Other than that, you can start from the the from the step that I have, like 4 plus square root 28 divided by 2, or this is gonna be like 4 minus 28 and then divided by 2, right? So that will give you the answer right away. Yeah. So yeah, so that's we can have it here. Okay. And from here you will have the answer gonna be x1 equal 2 and x2 equal that, right? So I would write zeros instead of roots, better say, because the reason was we are using the word zeros. Uh, okay. Yes, we're just using the word zeros in here, so I'm gonna use 0 only instead of using the word root. Uh-oh. Okay, so we can do the same way. Same way for part B and part C. Okay. But I would like to open B. So let's see. Yeah, I mean, let's I'm gonna go over a B here, and I say A is 2, okay. B is 2, C is -5, right? So then we can have x will be equal to square root of, oh, sorry. minus b plus n minus square root of b squared so well this minus 4ac everything divided by 2a. See, okay. And so 2 times minus 2 plus n minus 4 square root of 2 squared minus 4 times 2 times 95 divided by 2 times 2. Simplify time -2 plus or minus with 4 minus 4 or plus actually 20 times 2 gonna be 40 and everything divided by 4. Okay, so I have one more time simplify gonna be x equal to -2 plus or minus with 44 divided by 4. I mean, again, I say like I can from here at this point I can split it to be like, you know, x equal to -2 plus square root 44. I can just using calculators and handle this instead of trying to simplify if you don't like it. Or x equal to -2 minus square root of 44 divided by 4. And then what do you have? Okay, so I'm going to use calculators. -2, right? Plus 44 divided by 4 is -2 minus 44 divided by 4. Okay, and I mean, I want to check to make sure this is going to be the correct one. So 2x squared plus 2x minus 5. So we have -2.158 and 1.158. So I'm going to say 1.16, 2.16 and 1.16. Okay, so let me use this. So we have two Ks as -1.16 and 2.16. Yeah. So that's going to be it. Okay, so that's me move out. And again, this one we also have to use quadratic formulas, but I will skip this one and let you do that. Okay, so I can give you the answer key to practice with that. So I'm going to be x squared plus 3x, right? Minus 5. So I have -4.193 and 1.193. So I would say -4.193 and is 1.193. So approximately, you can try that, okay? and 3x squared minus x7. So let's write that. 3x squared minus x minus 7. So you get negative 1.37, 1.703. 7, and then this one will be 1.703. Okay. So I will skip these columns and I just move to the last one for this section. So all above information was trying to find zeros using, zero factorability and using quadratic form, right? The reason why we need to find zeros was, in the future, when you want to find the case as, when the cost function equal to the revenue function, and that's will make a um, quadratic functions. And when you try to set it equal set it equal zeros, right? Um, then you try to find a break-even point, which is at revenues at the point when revenue equal to cost. So so we had to solve for that's quadratic equations uh, um, by using the two methods above. So I would like to highlight these, right? And say we can use quadratic form formula or zero factor property to do this. Okay. So now, as you know that, uh, uh, that's when we have revenues equal to the cost, we're going to have break-even points, right? Or if you subtract both hand side by the cost, you will actually get like, revenues minus cost can equal zero. So, so I mean, we are given the function for revenue was x times 50 minus x, and the revenue and the cost function was uh, 26 minus plus 10x. So what I'm gonna do to set up, right? So I'm gonna substitute revenue function was x times 50 minus x first. And then I minus 4, I will put a penalty for the cost function, 336 plus with 10x. And then make it equal zeros, right? And you see, let me actually clean this up. And I'm gonna say cost. Here also is cost. And revenues. Okay. And this is revenues. All right. Uh-oh. Okay. Let me use the right one. Okay, so now I can just try to simplify this, right? So I would like to distribute like 50x minus actually x squared, right? And then minus 336 plus with 10x. Am I doing make the sign over here change, right? So that's equal to zeros. All right. So now we have to simplify. Okay, so I would like to move the x squared first, x squared term first, right? So I start with negative x squared, okay? And the 50x here combined with 10x here, negative 10x here. So when I have like plus 40x, right? 50x plus minus 10x, only 40x. And then the last term gonna be minus 336. And then I got equal to 0. Okay, so now we are having what? We are having a quadratic equation, okay? And we're trying to get zeros for the equation. I mean, we try to get the when x solution of this equation, okay? So we have we let's see if I can factor this one, right? Actually, you know what? I would like to get the answer key first, right? So let's try this one. Zoom out a little bit, see. All right. So here's a graph or function. I saw answer were 12 and 28, right? Okay, so let's come up with this. I have an idea already, so I will just do this. So this is factorables, okay? So A, C, I need to add A first, A, B, C first, right? A is -1. B is 40. C is -336. Okay, so A times C gonna be 336 and B equal to 40. Okay, so multiply equal to 336 and addition is 40. So gonna be 12 and 28, right? According to the two answer key there, I can have this number, but I want to make sure, okay? So I have 12 28. What is that? 336. Yeah, that's good. 12 plus 28 equal to 40. Oh, that's good too. Okay. Let me make sure if I made any mistake. Okay. Well, okay, so that's correct. However, I want to make some change in here. Seeing I am having A equal to -1, right? I don't really like it, honestly. I want to change it to be in positive one. I would like to multiply both sides by -1, right? So I change that's gonna be x squared plus minus actually 40x and plus 336 equal to 0. Okay, so now I don't have the negative. I just have 1 in here. And B gonna be negative. C is positive. So I make this negative here. And I will have then only these two numbers become -12 and -28. So I have -12 times negative 28 equal to 336. And negative 12 negative 12 minus 28. Uh-oh. Little slow. Okay. My laptop is kind of slow right now. I don't know what happened, but okay, so as you see, it's going to be equal to negative 48. 40 actually. I don't know why I put the 48. Okay, so okay, so that's satisfied. So then I can, because we have a equal to 1, so I can right away make my factor, make my quadratic expression to be in factor as x minus 12 times with x minus 28, which equal to 0, right? So then you can say, so x equal to 12, I mean, so x minus 12 equals 0, or x minus 28 equal to 0, then therefore x equal to 12 or x equal to 28 as the answer. So this will be it as, I mean, is as application, or I mean, interpret for this one. I'm gonna say break even points at x equal to 12, like 20 demand, or x equal to 28 demand. So that's gonna be it for finding the break-even point by hand. Okay, I will see you in the next section, actually the next chapter later, but for now, just thinking what we learn. We did learn about break-even point today. We did learn about how to find break-even point from decimals, and also we did know how to find by hand for the break-even point. Okay, I will see you in the next section.